Hey guys, this is Tom Cherryholmes with the next video in the Amiga Pac-Man series. In this video, we're actually going to take, now that we can make sprites and now that we can make blitter objects, we're going to take and put them all on screen at the same time. So with that, let's go ahead and get started. As always, I'll show you what we'll be making here. We'll go into my workspace folder, we'll go into sprites and Bob, and we'll take a look. What we have here are all four sprites on screen, all four ghosts and Pac-Man on screen at the same time, with Clyde being a blitter object. You'll see all of them moving across the screen against the playfield. And that's essentially what we're going to be making, and each of those individual objects are implemented as an individual task. To get started, we'll go ahead and come into our area, which I've prepared, and we have what we start with, which doesn't have anything moving, just the playfield all by its lonesome. Wait for it to delay and come out. And then we'll begin. So the first thing we need to do, we need to go ahead and bring in a couple of additional files. You'll see here in this particular workspace here, you can follow along, by the way, on GitHub. You can come into GitHub and look at Sprites and Bob and look at exactly what I'm looking at here, so you can follow along. I'll put the link in the description. The first thing that we need to deal with here is that we've got a couple of additional files here. We have sprites.h, which contains all of the sprite information for not only Pac-Man, but 3 of our ghost sprites as well. All the animation frames for Packy, but also all of the animation frames for Blinky, Pinky, and Inky as well. And the important thing here is that because these are sprites, as we've mentioned before in my talk about dealing with sprites, is that each of these are all are presented in the order that the hardware needs them in. For example, so for sprites, we need them in interleaved form. So bit plane 0 and then bit plane 1. Now you may be wondering why I have separate bitmaps for each of Blinky, Pinky, and Inky when they're all basically the same sprite with the same data. And the answer lies in the 2 fields that are at the top and the bottom of each of these. The simple sprite system will use these particular data areas to take and place these sprites within the context of the copper list that defines the screen. So we have to take and keep them separate. Whatever. They don't take up that much space. It's fine. So that's Blinky, Pinky, and Inky. And then, of course, we have bobs.h, which contains the blitter object information for Clyde. And since this is a blitter object, not only is there a bitmap, but there's also a shadow mask here too, so that we can define the transparent versus the non-transparent pixels like I covered in the previous video. You'll see that Clyde's information is stored consecutively with each bit plane in its entirety before the next one. Along with the other animation frame. Each ghost has 2 frames and multiple bit planes for each. So there we go. All of our graphic resource information there. If you want more information on how those graphics are made, look at the previous videos. I actually do go into detail on how these are made. And if we want, I can take and make a breakout video literally showing the process of me breaking apart the chunky pixel data and making the bit planes, all on its own video. Let me know in the comments. So, that brings us to here. We need to include these 2 files so that we can compile them in. Easy enough. We just need sprites and bobs.h. And as a matter of fact, to be nice, okay, so both of these are lowercase. We'll go ahead and keep them as is here. Okay, great. So now we have our now we have our bits and pieces. Now we need some functions here that are going to be passing through some various structures here. We need things for create port, create extended IO, create task, that sort of thing. And of course we have, like always, our screen and window definitions, our font definitions, and our color palette. Our color palette here has some repeated colors still. I haven't optimized the palette in the least. I will do that at some point later in these videos, but not today. That brings us to main. And all we really need to do in main is the same thing that we've done before. We go ahead, open our libraries, make sure everything's good, attach our font to the program and attach it to our window and our text attributes, open our screen with all of our information that we need, draw our border, and then finally take and start moving our individual objects. And for each of these, we need to create a task for each of these. So for that, we'll go ahead and create the variables down here, and then I will go up there upstairs and create the declarations for these variables here. We need a task for Pac-Man. And create task, of course, has the following parameters. The first is the name of the task. You can use find task to find the pointer to this task and return it back to you in another task. So you can potentially communicate with it, for example. You also need a task priority. This can be any signed value from positive 127, which is take over everything, to negative 127, which is only run when everything else, after everything else has had its chance to run, or the default, which is 0, which is, well, run whenever there's some idle time and there's nothing actually like needing to be preempted. By default, 0 is a decent task priority to start from, and then you can take and adjust the task priority as you need it. We also need a pointer to the function that we're going to call here. In this case, it's going to be PaccyTask with a capital P. And each task needs its stack, number of bytes that we're going to reserve for the local stack. 1,000 bytes is sufficient in this case. The other task, we're going to need one for Blinky. Much the same way. InkyTask. InkyTask. And ClydeTask. And at this point, all of the tasks will be started and they will all run to do their thing. Now, because this is a test harness and we're just testing to make sure that the objects can go on screen and do their thing, we're not communicating with them in any way. We're just running the task and we're waiting for a few seconds before we take and close everything down. On the other side of it, we also need our corresponding bits and pieces. Now, of course, we can do this. We could do it here, or we can choose, and a matter of fact, for this variation of it here, I'll choose to delete the task inside the task itself once it's complete. So we won't do it here. We'll just create the tasks here. But we need to go ahead before we do our calls to main here, and we need to add our tasks. These are struct tasks and pointers to them, so we need one for each one of these. InkyTask. There we go. Cool, huh? So now we've got all those. They're pointing up, and now we just need to make the individual tasks themselves to do what we need to get done. Cool, huh? So that means for each one of these, we have a task for Pac-Man. We have a task for notice that I'm keeping case. And at the bottom of each of these tasks, just to keep everything nice and neat, we'll take and put our delete task 0 as the last thing we do. Which means, because we're passing in a 0, that's a null. That's equivalent to a null. Which means delete the current task I'm inside of. Delete this task. Nice, clean, and neat. So there we go. We've got our individual tasks. Now all we need to do now is set up the rest of what we need so that these tasks can do something very interesting. For that, we need to use the graphic element system stuff that we've covered in the last 2 videos for sprites and bobs, and we need to take and use the tasks here that we've created to move them across the screen. So let's start putting in gel information. Oh, okay, great. First thing we need to do is we need to create our GELSinfo. And for that, we need, of course, simple sprites for BlinkySprite, PinkySprite, InkySprite, and PaccySprite. Get those nice and neat, ready to go. But now we need one specifically for Clyde. Clyde is going to be a bob, and bobs need both bob and VSprite structures. So groovy, right? Next thing we also need, because we're using the gel system, we need a GELSInfo to store all of our currently displayed graphical elements, displayed or otherwise, that we're going to be using inside this window. And we need our dummy VSprites. And of course, because we have our Clyde Bob here, we need a save structure. And for that, I'll just say whatever. So we'll just make an area here so that Clyde can save himself. Now, I'm actually going to be taking and putting a global X variable here. Maybe we'll do that. Maybe we won't. Let me think about that for a minute. I have right here in this, in the version that's up on GitHub, I'm using global X and I'm moving that across the screen. Maybe we can take and optimize that out. But of course, now that we've got these simple sprites that we've made, this blitter object that we've made, this VSprite that we've made, dummy sprites, etc. Now let's do what we've done before and start putting them inside our main program so that we can use them. So to do that, we need to go ahead, of course, and do InitGels, don't we? We can, of course, do that inside ClydeTask, but we can go ahead and also just put it inside the main task as well. Yeah, well, oh, it says I'm already here. Okay, so we've created our screen, created our window. We can get rid of this because we don't need to fill that. We just need to take and draw the border. All right, great. So now we've created our window, and we can initialize our gels. Recall that we need 2 elements to start the beginning and the end of the list. Dummy sprite A, dummy sprite B, and we need to initialize our GELSInfo. But we also need to now attach that GELSInfo to GELSInfo, right? Ruby. Now that we've got our gel system pretty much initialized, ready to go, I can come back and we can start working on the individual tasks themselves. Let's start looking at PaccyTask just as a start. One moment. Make sure I get here. Of course, PaccySprite, because Packy is a simple sprite here, we need to grab one. And we'll need a few temporary variables. Some position variables here, sure, why not? And a frame counter. Okay, great. Well, simple sprites as usual here. All we really need to do is set up our PaccySprite. And in fact, this actually can be statically defined if we really want it to be. We can either define it here or here. And in this case, we'll just define it here. We need to pass it our data. Say this is where our sprite data is. Our sprite is 16 lines tall. And it starts here at PaccySprite X and Y of BX and BY. At which point we get that. Now, of course, GetSprite, if GetSprite is less than 0, then we can just as easily return. We're done. Okay, fine, whatever. We can't really do anything else. But as before, we need to do what we did in the simple sprite video. Now that we've got our sprite, find its color registers, and call set RGB on them, RGB4 on them. Again, k plus 0 is transparent, so we really shouldn't deal with it, but we're wanting a very yellow Pac-Man here. So the red component is full blast, the green component is full blast, red plus green equals yellow, blue has no color component. There we go, and we just do the same thing here. We'll just kind of... We'll make it really simple here and just say, okay, Packy is as yellow can be. In this case, Packy only needs one bit plane here, so this one is just sufficient, whatever. But we're being overkill here. The set RGB4 call isn't very expensive. Now we can take and place him and move him across the screen. And we'll do this with a for loop. I did 240 in the example. I'll use 320 here. And the first thing we need, I'm going to use a pointer here. This pointer is going to point to the current frame of Pac-Man sprite data. And we're going to say, okay, if we've already done 3 frames worth of Pac-Man, which in this case, that's how many frames we have, then frame is equal to 0, okay? As a matter of fact, you know what? We'll just, we'll sidestep this for a minute. Let's see. Can I just go ahead? Yeah, I don't know. There's no real reason, because I already went through the basics of taking and displaying it here, so I'm just going to take and barrel forward. Okay. I hate second guessing myself sometimes. I'm just going to get to the meat of it. So if frame is 0, and you might be asking, well, can't you just use an array? Yeah, you can. I didn't here, but yes, you can. But I did this just for illustrative purposes. So for each of the Packy frames, we have 0, 1, and 2. We set the pointer. And the reason that we do that is that we turn right around and immediately do a call to change sprite, to change the sprite's content to our new data. Of course, change sprite needs a couple of parameters. The first is the viewport. The second is the sprite that we're going to change. And the third is the data we're going to change it to. Well, guess what? We define P up here. That's our new sprite data, and we have logic up here that specifies which frame we're going to show. Great, right? At which point we change it. We move the sprite. Again, similar things. You have a viewport, you have a sprite pointer. In this case, you have a global X and a global Y. So let's say global X and BY, sorry. Global X, of course, we're going to go ahead and just set that to 0. Because, you know, why the hell not? So now we've taken that, we've done that. Move sprite. We then immediately take and increase our frame, and we wait for the top of frame. And in fact, we'll actually use Pac-Man's task here to advance global X as well, just so that we can see something happening. Finally, we can, at the end of this task, once we're done, we can free the sprite and subsequently delete the task. If we didn't want to delete the task here, we could just do this and wait for our task to be deleted, or wait for a message that to have our task deleted. Whatever, it's our choice here. In this case, we're just going to go ahead. Once the sprite's done, we're done with the whole thing. We delete the task and we move on. So what does this look like now? Let's take a look. Let's go ahead, open up a CLI, and excuse me. Let's run our make. Hopefully I didn't have any typos here. We shall see very shortly. I always do, but you know, here's to pressing my luck. Yeah, we're doing all right here. Yay. So we're essentially going to be doing this pattern that I'm doing right here several more times for each of the moving objects on screen. And we're ultimately just going to see, oops, we'll fix this right here. 129 and 139. Okay. Darn, I thought I could get away with this. Okay, so what did I do wrong? 129, 139. What happened to you? What did I do? Give me a moment here and pause. I'm going to actually pause here and figure out what I did wrong. Derp. Okay. Well, it looks like I got one parentheses too many. That was a mistake. Okay. Oops. We'll write that again and we'll try again. Oh, it's funny. The errors that I've shown on this particular series are more to do with me just transcribing errors from the notes that are right in front of me. Oh, funny. I'm recording this roughly 2 days before Thanksgiving on 2024. Hope you guys have a good Thanksgiving. Okay, 139. We still have one more bug here. Let's see. Why are you mad? For 139. Oh, good gosh. I typed 4 instead of if. Dorp. Okay. looks like today is going to be, and this video is going to be a case of, oh, Tom is making silly mistakes transcribing from his original code. Derp. Another energy drink can in the can. So now we're at the 30-minute mark, and hopefully when we see something here, we should start to see our Pac-Man moving across the screen. We seem to be doing a lot of hard drive operations here, so this is looking good. Let's get to the second phase. Come on. I think we're going to do it. Yay! And no warnings either. This is awesome. Are you guys having a good time? Hope so. For me, this is fun. It's fun today, and it was fun back then too. Yay! Okay, linky, linky, link. Come on. There we go. And now we run our code, and we should have... There's Packy just moving along, doing great. Hi, Packy. Bye, Packy. Wait a moment, close the screen, and we're back. Okay. Now let's move along to the other tasks. We'll start with Blinky. Blinky, Pinky, and Inky are all going to have very similar tasks. So once we do Blinky, we're literally going to take and cut and paste it for the others, okay? With the main difference that we're going to change their color palettes. So now we start working on BlinkyTask. Okay. BlinkyTask, again, very similar situation here. We have a BlinkySprite that's going to be grabbed using GetSprite. And we also need a set of color palette indices. We need Vx and By, fine, Vi equals 0, and frame equals 0, okay? Very similar variables. BlinkySprite, pause CTL data equals Blinky, right, 0, BlinkySprite. Height is also 16 lines. X, Bx, By. And again, we use GetSprite. To grab a particular sprite. Now, I'm using a particular value here to say I want to grab this specific sprite, but I can just as easily say I want to grab the next, just give me the next available sprite here in the list here, and it will gladly do so for me. But I want to guarantee that I get an even numbered sprite so that I can get the number, so that I can scoot over and not collide with color registers here. Because remember, two sprites on the Amiga share the same color palette values here, and we need distinct color palette values for each of these sprites. So don't put that parentheses on there again so we don't deal with the same problem. And again, once we have the color registers here, we put in color values. Now, the first thing we need for our first color register, this is the background color for Blinky here. If you want to, go ahead and refer to the file in sprites.h. We need to deal with the first bit plane here, and this needs to be Blinky is red. So Blinky is now red here. The second color is actually white, the white of his eyes. And for that, we want full blast in all three color values. Now recall here, because I'm using setRGB4, and setRGB4 as its first parameter doesn't take the window, but it takes the viewport to the screen here, because we're changing the colors on a particular intuition screen, and each intuition screen gets its own color palette. Recall that. So we don't deal with a raster port here, we deal with a viewport. And finally, we need the blue of Blinky's eyes here. So that's 0, nothing here, nothing on the green component, but we need full blast on the blue component here. So yeah, red, white, and blue. Yeah, go America. Yay. So now we start dealing with, again, same indexes here. And move him across the screen. We've got him, we've got his color values, we've set his color. Now we can start moving him around. Now Blinky has 2 animation frames. So this means I can do a simple and check to see whether or not I need to take and just flip his animation frames every 4 frames or so. So if so, then I just take and flip him into the opposite frame. Frame equals not frame. So frame 0, frame 1, frame 0, frame 1. Bang, 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 bang. Okay. Finally, yes, Pac-Man. Viewport. And we get Blinky sprite. Again, you need the screen, the viewport, you need the sprite that you're going to change, and you need the frame that you're going to change into. So what is our frame? We'll do a ternary expression here, just a quick little compressed if expression to take and make this really fast. So what frame are we looking at? Frame 0 or frame 1? If it's frame 0, we pass in the pointer to Blinky right 0. Otherwise, Blinky right 1. That's it. And then we move sprite. And recall that we did global X before, and that's being moved by Pac-Man, so we don't need to increment it here. So it's just, okay, great. Global X, VY. We wait for the top of the frame. And then finally at the end, when we're done, VSprite, Blinky P, Blinky SPR, and then we delete the task and we're done. Right? Okay. Execute make. And let's see if I made any typos this time. It's very fortunate that the project that I decided to do here maps very cleanly, for the most part, to hardware sprites, and that we really only needed to use one blitter object for one ghost here. Different projects will need a different set of object resources. So it's your responsibility as a software engineer to basically figure out how to allocate those resources. In this case, oh my god, freaking typo. In this case, sprites are very fast. Blinky. Oh, good god, I see it right there. Hi, I'm Lizdexic. How about you? One Nation Underdog. Try again. And yeah, this is kind of this was the reality of software development at this point in time. It took time for a compile to come back and to see the results here. And sometimes, especially as your program, as you started building the individual pieces of your program and putting them together and building larger and larger pieces, linking them all together, it took longer and longer for your compiles times to come back. I saw compile times in the days of time-shared machines, you know, with compilers written in Fortran running on a PDP-11 or similar on timeshare. You know, when you're sharing a system with, you know, 10 or 15 other programmers, you know, your compile times might take anywhere from 5 to 10 minutes, you know, each pass. So you really kind of, you know, you really had to make sure, absolutely sure, that everything that you were doing was, you know, on the up and up, and tried to make as few mistakes as humanly possible. And believe me, that was even worse back in the days when you would take and not even have an interactive compiler that you could take and fire off. You would literally take and just write your program down, hand it to a key punch operator. The key punch operator would take and enter their program in as a series of punch cards, and then they would run the compile back, and you would, you know, come back, you know, some hours later, only to find out that you made a typo and have to repeat the whole process again. Meh. So, yeah. Anyway, let's see how we're doing here. If we're doing good, we should see Paccy and Blinky moving side by side. And in fact, we are. Look at that. Just hammer right along. Looking great. Okay, let's get the rest of it in place. What do you say? Okay. So we're getting down to the bottom of this. All we really need to do, 9/10 of this can all be moved across. So we'll just take and cut and paste it right now just to get this across. The whole purpose of this particular test right here was to make sure that we can actually put all of these objects on screen at the same time and have enough time to do so. And it turns out, yeah, we can. So we'll take and move this across. But, you know, this is just part of the process of dealing with all this. Escape W, bam, move it across, and at this point I will take and just do a little bit of Blinky, and we'll change that to Pinky. Search again, and we'll say and again, PinkySprite. Now just take and do all this, all one right after the other. Pinky, 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 pinky. Okay. Blinky, pinky, blinky, pinky, blinky, pinky, blinky, pinky, blinky. And finally, okay. So now we've got all that moved. Now we just need to take and change where Pinky actually winds up on screen here. For this, we'll change his BY position, her BY position here to from 20 to 36, and that'll put her right underneath Blinky. Okay. So, oh yeah, let me change. Make sure. It's a good thing. Blinky, 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 Blinky. Okay. PinkyTask. Okay. PinkyTask. All right. Oops. Let me actually get back where I need to get back here. Case sensitive. Okay. So now Pinky's in place. We need to change her colors. Now Pinky needs slightly different colors here. For this, we need a pink color. So for this, you would think a combination of red and blue, well, that will get you magenta. We need to take and add in a good dose of green here so that we can get a nice, intense pink color. Groovy, right? And we also need to make sure that we position our sprite and ask for sprite number 4 here so that we can again guaranteed to get color registers that we can change here. Okay, great. Boom. So there we go. It works the same way. We're just changing Pinky's data. All good. So now if we press our luck right here, we should be able to build and see Pinky on screen alongside Blinky and alongside Packy at the bottom. I think we'll be good for a second pass. Yay, okay. Looking good. And no warnings. I love it. And you can see our previous compile pass was 10,512 bytes of object code here, or maximum code size here. And see, these are all very small test harnesses here. And even the addition of Pinky's own task code we'll see right here isn't that much. You know, a couple hundred bytes. Sure. Okay. So here we go. And now we see Blinky and Pinky just moving along. Looking good. Okay. Now we do Inky. Same way. Mark this sucker and move it across. So now we just need to do the same thing I did before. And this time we're going to change Pinky with Inky. Making sure that, yeah, I call here just to make sure I don't miss any. And the thing is I don't want to go down too far. Now the main difference here with Inky, again, so you see that Blinky started with sprite number 2, Pinky number 4. Now Inky needs number 6. We'll go ahead and change that while we're thinking about it. And again, Inky, 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 and Inky, and finally VSprite Inky, and that's good. That leaves us finally with the changing of Pinky's background color. Now, or with the Inky's background color. Now, Inky's background color is basically cyan. That's Inky's color. But for that, we don't want any red in the color component at all, but we want green and blue to be full blast, because green plus blue equals cyan, with the other two colors being exactly the same. Okay? Again, the frame logic is exactly the same, because all of the sprite data is exactly the same. But we have to maintain separate copies of it. Finally, VSprite, delete task, ready to go. Okay? And if we execute make, this should be good. And in case you guys are wondering, if you're wondering if I'm going to change my linking and building process for when we bring all this together, my answer is, well, no. I'm actually literally going to be using a script to take and bring all of this together along with a link file that the A-link can actually specify here to take all the modules and link them all together into the final binary. We'll also, of course, go into all of the final packaging processes that go into taking and putting everything together into a finished product when we get to that point. But we have a lot more to do before we get to that point. We have to take and implement things like the menu logic. We have to take and implement the overall game logic. Dealing with collisions, that sort of thing. All of those bits and pieces. We have a lot more that we need to do in this particular series. We also need to take and do a deep dive into how I'm going to be doing the music for the music breaks and all the sound, etc. So you guys can get a good feel for how I'm handling all of that using the audio device and the timer device, everything else. So. Yeah, and so on. So now with all this, you'll see right there, see what happened right there? Oh, you can see right there, there's a good example of sprite priority. And you can see that, the order that the sprites are actually in here. The lower number sprites have higher priority, which means Pinky gets rendered on top of Inky. So a little mistake on my part, but I think a very good one here to really show kind of the point here. So the way you deal with that particular problem is that you just take and scoot it down a little bit, and we'll see Inky the next pass here. we'll just continue on, because the last major piece here is to take and handle Clyde, which Clyde is actually handled as a blitter object, which is going to require slightly different code. But it's going to be very much like what we did for the Clyde Bob task in the previous video here. So that's going to come full circle. So for that, what we need to do here, we need to start with an index that we're going to use, sure, and a frame counter that we're also going to use, sure. The first thing that we absolutely need to do, because we've created the Clyde Bob, recall that we created Clyde Bob and Clyde VSprite, sorry. Clyde Bob and Clyde VSprite here, up here, that we need to take and connect these two bits and pieces together. That's easy enough. All we really have to do here is attach the pointers to each of these data structures so that the GEL system can actually take and reference them, like I mentioned in the last video. Those two are now connected together, and now we can actually start filling in the information needed for Clyde to be able to be visible. Clyde is 16 lines tall. He is 1 word in width, which means 16 bits. 16 pixels. He's also, at the moment, he happens to be a 4-bit plain blitter object, but we can actually take and get that down. We can optimize that quite a bit. So we need to specify that all of his bit planes need to be moved over as is. The plain pick and the plain pick image field works exactly the same as it does in Intuition. So whereas you can specify that certain planes we won't be putting any data in them, you can choose whether or not those need to be all filled with zeros or all filled with ones here. We're going to take and copy all the bit planes over as is, so 00F. Okay, fine. Finally, we need image data. And that will point over to Clyde facing right, frame number 0. Okay, fine. And since it's a blitter object, we also need a corresponding shadow mask to tell which pixels are transparent and which ones are opaque. I showed you that at the beginning of this video. We have X. We have Y. He starts at the bottom right next to Pac-Man. And of course, we have our save buffer. Because this is a blitter object, it's being drawn on the playfield, so we need a temporary place in memory so that the blitter can take and temporarily copy the contents of the background at that particular point before the image is composited so that they can be restored when the object is moved. Finally, we need a set of flags that are set so that we can say we want to save the background, and we have the save buffer to do it, but we also want to overlay, which means we want to use the image shadow mask here to take and say which pixels are transparent and which ones aren't, so that we don't just obliterate the background in the process of displaying this blitter object. And because I can't remember whether or not which one of these actually needs both of these, we're going to set the same flags to both. It seems to work. If anybody can take and clarify that, please feel free to clarify that in the comments. Oh wait, I already did that here. In my original code here, I decided to do the initialization here. We don't really need to do that here. So now that we've created our, we've filled out our data structures here, we can immediately take and add our blitter object to our window. There we go. That's all we got to do. And since this is the only blitter object that we have, we're going to use the same optimization trick that we did in the previous video and sort the graphic list only once. If you had different virtual sprites that were all being moved in and out and over and around, along with blitter objects, you would need to call this once per frame. This isn't changing, so we don't need to do that here. In this case, we only call it once. But we go ahead and we do the same trick here, moving across the screen. Now, the same basic frame logic that we use for the other ghosts is also here. Has it been 4 frames? If so, we take and change to use the opposite frame. And then we basically just say, what frame are we on? If we're on frame 0, use R00. If we're on frame 1, use R01. And finally, since this is a blitter object, same thing. What frame are we on? Use the appropriate shadow mask. Okay, great, right? And then finally, we go ahead and set the VSprite position for Clyde to whatever global X happens to be at the moment, and draw the result. Passing in, of course, the raster port, which contains our GELSInfo. And the pointer to our viewport, because again, we might be dealing with VSprites, and blitter objects work on raster ports, VSprites work on viewports. Funny, isn't it? But you need both of them because the GEL system literally takes and supports both of them at the same time. And finally, we go ahead and wait for top of frame. You'll notice that in each one of these cases, we're waiting for each task is waiting for the top of frame. This is perfectly legal, and it is exactly what was intended to be done. So in this case, again, wait TOF waits for the top of the very next frame using a copper list interrupt. So this call to wait TOF is not expensive at all. It's not having to do any idle waits to make it happen. It's just waiting for the signal from the interrupt to come back to the task, which that happens. Okay, great. The task takes, at this point, the task goes into wait, and anything else that might need to happen in the meantime can happen. So this is another variation of the wait command. Just like wait, just like wait port, just like do IO, etc., etc., etc. Using these functions right here effectively will allow you to make the most use of your individual tasks and have lots of little tasks and not worry about them starving for resources. Because it was all designed so that this all could work together. Anyway, but I digress. At this point, we're done. There is no free sprite here because we're not using sprite, so we just immediately go to delete the task. Because what's going to happen when this window closes down, the GEL subsystem and the GELSInfo that's attached to this task will automatically be shut down with it. And anything that's attached to that gel, such as the blitter objects and not will automatically be removed. So we don't have to do any other cleaning up in this case. Delete task 0 and we're done. Okay, 105. Just checking to see where we are. 384 lines. That's a nice power. You know, that's a nice power of 2 number. Okay. That's a nice number. Now the irony of this is, if I were to use the VSprites, the virtual sprites part of the GEL subsystem, the code for Blinky, Pinky, Inky, and Pac-Man would actually be a lot closer to the code that's being used for Clyde at the moment. In fact, it would almost be identical. But I'm not. And the reason that I'm not is because I don't need to multiplex the sprites in the system. I don't need to consume the amount of resources that actually takes. I can simply just use the sprites. I can use the sprites directly, very quickly, and still have all the resources and time that I need to take and get things done. And as we can see here, this works out quite nicely. It's okay, looking good. We got past that with no errors here, and hopefully by the time this takes in links, we'll see all of our objects moving along the screen at the same time. Just having a good old time here. Okay, doing good. Let's see how this looks here. Yay, we have all of our objects on screen, just moving along, doing great. Having a good old time here. Plenty of time to do what it needs to be done. And all of this happening in a nice system-friendly way. Okay, I think mission accomplished. On to the next video here. So, what's coming up in later videos? Well, the next video is actually going to be dealing with the Intuition menu system and Intuition's very unique menu system. We're going to be showing how to take and create all of the data structures and everything that you need so that menus will work. So you can take and select game options and the like, and we'll be using, like I said before, both the text form of menus and the image form of menus here, menu items, so we can more effectively, do what we need to do. You can see the unique aspects of what makes Intuition have such nice menu systems here. And you'll also see, of course, there reacting to those menu items, how to take and properly process those events. So that's menu, that's the very next one. After that, we're going to take a nice big long dive into the sound system here, and using it to take and play the Pac-Man theme, and how I actually take and implement the music playing routines for that to happen. And as you can see, they're doing it in such a way that it actually can stay, reasonably, stay locked together quite well. So those are our next 2 videos, and there are more to come even after that. But hopefully you guys are really enjoying all of this. If there are directions and things that you feel I need to cover, please feel free to take and make comments in the video. If you like this particular, if you like this content and want to see more of this content, as always, take and like and subscribe. I promise, and my personal solemn promise is that I will not be attaching monetization to these videos here, so you guys won't be having commercials. This is my promise to you. My income comes from elsewhere, so I can do this quite nicely without needing to rely on what little dash of ad revenue I might get from these. So anyway, I hope you guys enjoyed this, and until next time, guys, have fun.